Cool. All right, so I'm Tom. I've been working on the Zap desktop wallet for the last 6 months or so. And so yeah, if you're not familiar, like Zap's, we're sort of trying to build consumer-facing like Lightning applications. We currently got an iOS app and a desktop wallet, and they're pretty similar. Like interface is pretty similar between them, but they've got a slightly different focus. So I've really been working on the desktop wallet, and like, can I just get an idea actually of who, like, how many people here have like used Zap or know of Zap? Quite a lot. No. Okay, like that's probably about like 80–90%. That's awesome. Cool. So I want to take you through a couple of different things. So first, I want to just talk a little bit about my experience of building on Lightning and kind of what I found is involved in that. And then I'm going to take a bit of a look under the hood of Zap. Like, I'm going to get a little technical, but I'm not going to be showing code samples or anything like that. So. But I want to give you a sense of like how it's interacting with Lightning and kind of like what the communication stream's like and what we're kind of doing underneath the kind of interface that you guys see. I'm going to show you some of the new features and things we've been working on. And then I want to just kind of touch on some of the like challenges that I've kind of faced and some of the insights that I've got from kind of working on this stuff over the last few months. So starting off, like, you know, I say building on Lightning. You know, I think the first thing I would say there is actually that, you know, Zap is basically a web app at its core. So like technically it's like a React application and it's running in Electron. You know, but if you've done like web development before, or you're kind of familiar with client-server architecture, is pretty similar. Like, you know, whereas when you're building websites, you're kind of like using maybe Stripe, you know, Stripe API or PayPal API to make payments. Like, we're just using LND under the hood, and you know, everything you're doing in the interface there is just literally sending messages over to LND, and kind of LND is doing all the interfacing with the Lightning network. So we're getting kind of real-time data back from LND, and we're kind of presenting that and allowing people to interact with the network without really knowing that's what they're doing so much. You know, and like the tools and processes that we're using to build out the app are really similar to like if you've done any web development. So like, you know, it's literally a JavaScript application. So, you know, I think you guys, you'll probably be familiar with that sort of thing. You know, we're running continuous integration with like Travis and AppVia. We're using kind of Jest for our automated testing. And we have a pretty much like a zero-touch deployment process whereby when we commit everything to GitHub, like every commit kind of triggers a build, which triggers the test suite, which triggers a kind of like packaging up the application into the Electron package. That gets uploaded to GitHub. And so we kind of always have like the latest version of Zap available there on GitHub for download. We actually just publish like when we're kind of ready to do a release, we just publish the kind of most recent version of that. But we've kind of always got those builds available in the background. But like, you know, essentially it really is just a wrapper around LND. And we've kind of built into it support for running LND locally on your machine. So you can run LND on here like via Zap Desktop. You can also connect it to a remote node as well. And you know, in both cases, it's just working as remote control. Like the difference is that when you're running like LND locally, like you're communicating with gRPC locally on that node. So we basically have kind of two different JavaScript processes running. We have the browser environment, which is basically like a Chromium environment that runs inside Electron. And that's basically giving the browser window, essentially is what you're seeing, is literally a web browser with the React application running in it. We've got LND running in the background, and we're using the gRPC API to kind of communicate between the two. And then because we're managing like LND as an external process, so we have the LND binary packaged up in that Electron app, and we literally use like node spawn, so we have full like Node.js facilities within there, and we just literally use node, we spawn that process, and we have a finite state machine that sits on top of that LND process so that we can kind of more easily manage transitioning it from one state to another. So like when we boot up the app, we kind of set the state machine in a ready state, and then, you know, when you kind of access a wallet, we kind of you know, transition to a running state as we start the process, and we attach some event listeners to the LND log output, and we kind of you know, monitor the process, and we can stop it and restart it and things like that. We've also got some supporting infrastructure, sort of more back-end stuff. Like specifically, we have a cluster of BTCD nodes, which are like Bitcoin full nodes. So if anyone's not familiar, BTCD is like a full node implementation, similar to Bitcoin Core. And we have a few instances of that running. We currently run them out on the Google Cloud environment. So they run in, we have a Docker containers, and if you go to our GitHub, we've got 2 different Docker containers. We've got an LND one, and we've got a BTCD one. And we use Kubernetes to deploy those out to Google Cloud. And then we have the actual full blockchain data is stored in Google persistent drives, which we attach as stateful drives to the node instances up on Google Cloud. And so we have those because when you're running LND locally on the machine, LND connects to our BTCD nodes. It connects to a couple of them in parallel, and it synchronizes the blockchain data from those nodes. If you're using the remote node, then it doesn't touch our BTC nodes at all because you're just connecting to your own setup where you've got your own full node. So kind of diving a little further under the hood. So when you start up the app, first thing we do is we go through some sanity checks, and we kind of check the file system. We make sure that your wallets are where we expect them to be. So we basically store, when we start LND, we create a wallet which creates an LND directory in a specific location. It actually gets stored in the user data directory from Electron. So it'll be in a slightly different place depending on which environment you're running on, like Mac or Windows, whatever. But it's essentially application state data. And we also use IndexedDB. So within the Electron browser environment, we're using IndexedDB, which is a native kind of browser-based database. And in that, we store some persistent data. We don't store a lot, but we store your wallet configuration. Because when you spin up a remote connection, you've got to tell LND where's your macaroon, where's your private, where's your certificate and things like that. So that configuration we store in IndexedDB, and we also store some user preference data. So what theme you're using, whether it's the light theme or the dark theme, or what language you're using or what currency you've selected. So there's only a small amount of data that we're using currently. Previously, we were using just files on the file system. We just had a little JSON file with a little bit of config in there. And we found that as we start to sort of build it out more, that we need something with a bit more of a rich API than just accessing a file. So IndexedDB is really lightweight, and it's kind of built into the Chromium environment. So we're kind of using that for our persistent data. And I think, as we start to sort of build things out more, there's probably some nice things we can do as well by having access to that database. So the next thing, once we've booted up the app, we then send the user into this kind of onboarding process. And I think this screen kind of embodies what we're trying to do with Zap, which is provide something that's simple and easy for end users who aren't so technical. And I think we're probably partly the way there. There's a lot of things that can be done to continue to make it more user friendly. But you just got a couple of basic options, whether you want to create a wallet, import a wallet, or connect to a remote node. And we have a form wizard to just collect up that data. So we collect up the data, we store it in. We're using Redux within React, so we kind of store that data in Redux, which is our kind of persistent data in the browser while we're kind of going through this process. And then once we get through that process, we go and kind of spawn the LND. If you choose to select the local node, now this is where we actually start to spin up LND. So we spawn an LND process, which basically gets gRPC running up on port, we actually select a random port, but it'll be somewhere around the 10,009 range, which is 10,009 is the default port, but we have a range of ports that we use. We scan for a free port, start up LND, which gives us that gRPC interface. We make an API call into it, and we tell it to generate a seed. We spit that back to the renderer process, and we present that on the screen for the user, and obviously ask them to write it down. And then we actually kill that LND process. And that's kind of actually a new thing we've started doing because some of the stuff I'll show you in a bit, some of the new stuff, you can actually kind of move in and out of this part of the app. But like, it's actually something I've been working on recently, and I found that, like, I'm really interested to know if someone knows a better way of doing this, because, like, if we just want to generate a seed, like spinning up a binary process and like getting access to an API and like connecting to gRPC and making an API call, like it seems kind of like overkill just to generate a seed. I mean, if there was like a native JavaScript library that we could use or something, it would be
BIP39. There's a BIP39 JavaScript library.
Is there?
There's probably also Bitcoin.js that can do it, or the other one.
But the seed format's slightly different for LND, I believe. They have like an AZ. It's not standard BIP39.
Then you're out of luck.
Yeah, exactly. So, you know, but I think these things will come. You know, and
it's probably just one little Go file that maybe could be converted to JavaScript.
Yeah, absolutely. Yeah, exactly.
WebAssembler.
Sorry?
To WebAssembler. That's a bit overkill, maybe too, but sounds like fun. Yeah.
Yeah, and maybe someone wants to pick it up, we'll happily accept it. So yeah, so you know that's what's happening here. Like the other route, when you're connecting to a remote server, so like currently, like it works and it's functional. Like we get a lot of support requests in Slack for people like trying to figure out how to do this. Because if you've ever tried to connect to a remote node, like you got to get 3 key pieces of information. You need to know the host name and the IP address of the machine where LND is running. You need to know the port where LND is running. You need to get a TLS certificate and an admin macaroon file from that server, and you need to copy those to your machine, and then you need to tell Zap where those files are. So, even just in saying that, you can hear like the friction that's involved in that. If we're trying to build something that's like consumer-facing, like easy-to-use Lightning wallet, it's really not easy to use. And
if it runs on your own machine, I assume these are all defaults that you can get.
Right. So this is the point. This is the case where you're connecting to a remote node. So imagine you've got a piece of hardware at home that's running a full node for you, and from your laptop wherever you are, you just want to be able to connect to that, right? Or you've got like a BTCPay Server instance, or anywhere where you've got a remote node. So in order to do this, you actually need to like shell into that node. You need to navigate into the LND directory. You need to find these 2 specific files. You've got to copy them over to your local machine. You've now got to store them somewhere on your local machine. You've got to like enter in the path to where they are. I mean, we could have a button where you click browse and you could navigate for the file. But you can see the friction in that, and also like that's inherently insecure as well, because if you think about it, like if you've got those files, the TLS file and the admin macaroon, you basically have full control over that Lightning node. So whoever has those files can control the node. So they're your keys essentially, in a sense. So we're asking you to copy those across a network. So I mean that's going to be pretty insecure in most situations, and we're asking people to store them somewhere. Like where do they put them? There's no like standard place. So this is the current situation. There are definitely things we can do to try and improve that process, but.
So the whole point of macaroons is that you can give partial permissions.
You can give partial permissions, yeah.
Like the LND server itself should be able to generate something that you download, or some QR code. Yeah,
it can exactly. But in order to have a wallet like Zap, you need a macaroon file which gives you permission to send money.
Yeah.
So anyone who's got that macaroon now has the permission to send money. There's no way around that. I mean, if you want a wallet, you've got to be able to send, right? It's like the most basic functionality.
Why are you saving them as files?
Well, that's just what we do currently. I mean, we can certainly use like the operating system's like private store, which would be a better solution. But you've also still got to get the user's got to get that data to us somehow. So they've either got to go in. We could provide like rather than asking them to enter in a path to a file, we could have somewhere where they just paste in something. Now it gets a little more complex because the macaroon is actually a binary file, so you can't go and copy paste binary data into a field in a web browser. Sorry? Yeah, you can base64 encode it. And so this library here, Zap Connect, is a library that we wrote to kind of like help this process again. So Zap Connect is a little Go like application that's compiled into a binary. You can install Zap Connect on your LND node where LND is running. And when you run Zap Connect, it will generate a QR code for you that's a representation of the macaroon and the certificate and the connection info you need, like host name, port, all these bits of information. They're encoded in the QR code. And then with the iOS app, you can just scan that. So like in the iOS app, it's pretty frictionless. You literally install Zap Connect on your Lightning node, you run Zap Connect, you get a QR code, and you go connect with your phone, and you just scan it. Yeah.
So how do they do hole punching on iOS? I mean, because you have to have an open port.
You do.
This is just that,
yeah.
I mean, we had this problem in the 90s. It resurfaces every...
Yeah, exactly. So again, another questions we get all the time in Slack is like, there's a few different like pitfalls here. One is like, people have got to open up their port. They've got to make sure their firewall is forwarding packets. It's definitely fraught with difficulty, yeah.
I don't know if macaroons support this, but what you could do is generate a private key on the desktop app and then give the public key to the LND server and then make it generate a macaroon that says only the signer of this public key can actually like communicate with me.
Yeah, that's kind of interesting.
Back and forth with the QR code, but at least then you're not sending any private keys over the wire.
Yeah.
You're sending public keys.
Yeah, that's an interesting idea. You know, I think like that's cool. So yeah, I mean that Zap Connect like works really well with the mobile app. And actually, there's two ways you can run it. You can generate a QR code. You can also just generate like a JSON snippet as well, which you can copy and paste. And that JSON snippet kind of contains the macaroon in it as well. So there are things we can do. I think that's a really interesting idea. Something maybe we can chat about that afterwards.
I read the macaroon paper like 10 years ago, so don't interrogate me on it. But I remember that they said things like, oh, you can like have your Flickr photo album, and then you can give somebody a macaroon that says if you're logged in with your Yahoo account or with or your mom's account, then you can do this. Like they had some fancy ideas about permissions to solve this type of problem.
Mm-hmm. Okay. Like one of the final ways that we kind of built things we built into the app in terms of connectivity is we built an integration with BTCPay Server, and this is another kind of way around this kind of issue. So we worked with Nicholas, who's the developer of BTCPay Server, to build out this configuration format. And he now has in BTCPay. So if BTCPay is like a store that merchants can use to really easily spin up a Lightning node and have a store and point of sale device and things like that. And we're seeing a lot of merchants kind of using that. But now in BTCPay, you can go in and you can say, show me my connection string, and it will show you a QR code or something you can copy and paste. And you can just copy that, paste it directly into here, and hit next, and you're done. So it's a bit more frictionless, but that only works because on BTCPay they've already got the infrastructure to generate this kind of it's basically doing what the Zap Connect library is doing, something very similar, generating something that you can just copy and paste over. So once you've made your connection, the next thing we do is we start synchronizing. I mean, if you're running LND locally, then we kind of go into LND synchronization process. And this, something was really tricky to build. And our implementation of this is I would say, hacky to say the best. But the problem is that with LND, you've actually got no idea how far through the synchronization process it really is. And the way that we do this is we attach a listener, because we've got the LND process running locally on the machine, and we attach a listener to the standard output and standard error of the LND process. And we run regex on every single line of log output, and we basically listening out for things that give us some kind of hints as to what's happening in the sync process. Some log out, we've got a list of probably 15 or 20 log messages that we know are interesting to us and give us a hint as to whether a new block header has just been downloaded or some commitment filters have been downloaded. It'd be nice if LND had a stream that you could just connect to. LND has this kind of bi-directional streaming, kind of like WebSockets type thing, where you can get data just fed to you in real time. And they have it for some stuff like transactions and invoices and channel data. I think you can get data just streamed for you, but you can't get any of this state data streamed to you currently. PR 1355 they're trying to build like support for Prometheus, which is a sort of monitoring system which allows you to tap in and get all kinds of metrics from LND, like about memory usage, and I think they're talking about including things like streaming, like sync data and stuff like that. So if there was something like that and that was exposed over the gRPC interface, we'd get a lot more insights into what's going on in LND. At the moment, it's pretty rudimentary and it's limited because like we can only do that on a local process we're running. Like if we've connected to a remote node, like we've got no way of knowing what's going on in that. Like if you run, LND has an API call that's called getInfo, and when you run that, it has like a flag in there that says synced to chain, and it's like, it's true or it's false. So like when the synchronization process takes several minutes, you need to kind of give the user some feedback as to what's going on. Another kind of shortcoming that we found as well is that even just knowing like what the current block height is, like what's the latest block on the blockchain, what's the current block height number? Because when you connect to LND and it starts synchronizing, like LND will tell you what it thinks is the latest block. Like it'll tell you what the latest block that it has. But if LND itself is still in the process of synchronizing with the blockchain, like that, the latest block that it has might not be the actual latest block. So we have to make a call out to a block explorer. Like I think we use blockchain.info, and we kind of figure out what the latest block is so that we can show the progress, incrementing. In fact, even that's like fraught with challenges because we found cases where like blockchain info would go down. So we actually now make 3 different API calls out to 3 separate block explorers, and whichever one gives us a result back first, we use that to assume that that's the current block height, and then we start pulling in the log data. So
why are you not just pinging the full node?
We don't have access to the full node. We're only connected directly to LND, and LND might be talking to a full node that's on a different machine somewhere.
Okay, but LND cannot relay that piece of information. But that sounds like a simple pull request.
So when we're running LND on here, we're running it in neutrino mode, and that's basically talking to our BTCD servers.
But
yeah.
You said you had several BTCD running on Google Cloud?
Yeah.
Okay, you can connect to those?
Yeah, we can. Like, there's different places we can get that data from, but it would be nice if LND, because LND is like our primary interface for like everything Lightning. We can kind of do 90% of stuff, but it's that extra 10% where we have to kind of figure out workarounds. Whether it's calling into BTCD or.
Sorry.
Yeah.
Where's the neutrino protocol coming in? So the LND node on your local machine is connected through neutrino to the rest of the Bitcoin network?
Right, so when you're running it locally, you're running LND locally, and LND is running as a neutrino client, which is connected to our BTCD full nodes. So the neutrino is the light client implementation between LND and between the full nodes.
So can LND also be run with a full node with the local full node?
It can, yeah.
It doesn't use any of the neutrino stuff, right? So then
that's right. But we don't want to be downloading gigabytes of data. Like I think when you use neutrino, like I think with testnet, like most of my LND directories are like 400 meg or something like that. And you can download that pretty quickly. Like this actually currently it takes about 5 minutes on testnet. Like if I'd done this like a couple of months ago, that would have taken about 15 minutes. So there's a lot of improvements coming. Like what they've done is they've now made it so that neutrino can pull the block headers and the commitment filters in parallel, and it can pull them from multiple BCD nodes at the same time. So we're kind of getting like 4x what we used to get. And I think that they're starting to work more actively on the neutrino support now. So like I think there'll be some more improvements. Yeah. And that's testnet as well. So like mainnet is much smaller and would be faster again. So. But I think another thing to just point out here. So on the right, you've got like the channel like management piece, and this the idea here is that you can essentially once the wallet or LND really has built up a picture of the network, which as I said can take some time, then you can like go and start establishing channels with nodes. And if you turn on autopilot, it will do it for you, and you can just tell autopilot like by default we have it set. I think we just use the LND defaults, which is like. I think it allocates 60% of your funds over a maximum of 5 channels or something like that. So it should theoretically give you like a good routing into the network, but like in practice that doesn't really happen at the moment. So the channel management piece, like you can click on one of these channels and you can see like how much balance is in each channel and things like that. But like ultimately we'd like that to sort of disappear into the background. Maybe like we can just collapse it or something. Maybe eventually we can hide it away in an advanced settings page. But like currently, there's literally no way you can use the wallet without being able to kind of inspect your channels and manage them manually. And I think that speaks to a bigger point, which is that it's difficult for you to use the wallet without actually knowing what a channel is. So we're talking about building things that are for like mainstream, like if you need to know what channels are, like we're not there yet. Yeah, cool. So I wanted to show you a couple of new bits and pieces that we've been kind of working on. Some of this is already in the master branch. Some of this is kind of going through review at the moment. So the first thing is the payment and the request forms. If you guys are familiar with Zap currently, you might see some differences here. We started building out support for like fee estimation, which we can get about 50% of the way there currently. So in terms of making off-chain payments, so like Lightning payments, what we do is we send the payment request to LND. We use the query routes API call, and we ask LND to give us like a list of up to 10 routes, and it will return those to us in order of like lowest fee to highest fee, and we could then present the user with the lowest fee that we've got and the highest fee that we've got. So we give them the range of what we think it's going to be, and when they hit send and we send that payment, we take the maximum fee that we got from our list of 10 routes and we apply that as a fee limit. So like in the current version of Zap that you guys might have, when you actually send the payment, like we just blindly spit it out to the network. So basically, if it finds a route, it'll send on that route regardless of what the fee is. So here we're kind of showing the user up front, like what's the kind of possible range. And like we generally see that this is like between like 1 and 3 Satoshis or something like that. So they're pretty low. But you know, it's important for us to say, well, if we're showing the user that it's between 1 and 3 Satoshis, then like we've got to cap it at 3. So when we make the send payment call into LND, we tell it the maximum fee that we're going to apply, which is the highest of the fees that we got back from query routes. And, you know, if it manages to send it over one of those 10 routes, then fine. If it doesn't, or you know, so when you tell LND to send the payment, like it will just basically keep trying routes until it finds one that works, or it times out. So we kind of like make sure we put a hard stop in if the fee limit's been reached. In terms of the on-chain fees, we've had some challenges here because like LND doesn't currently provide an interface to, like it doesn't provide like a fee estimation interface, like either on REST or gRPC or whatever. So there's no way for us to know up front like what transaction fee is going to be applied. I mean, so more specifically, like what we do currently in this latest implementation is we call out to the, like, what is it, the BitSeeds, like, there's like a fee estimation API, I think it's BitSeeds, the 21 thing. And we find out what the current sort of estimated fee is to get something in within like a few blocks. And we can get that per byte fee rate, so like, you know, whether it's 5 Satoshis per byte or something like that, and we can find out what that is. But what we can't do is know, like, we can't actually generate the transaction up front, so we can't know how big the transaction is, or how big it's going to be, and therefore, like, how much the per byte, Satoshi per byte fee, like, extrapolates out to as a full cost of the transaction. So, yeah.
Why can't you know the size of the transaction?
Because LND doesn't let you create a transaction up front currently. Like with LND, you can basically just say make payment, and inside LND, like it creates the transaction, it does the fee estimation, and it applies a fee rate, and then it sends out that transaction. But the API doesn't give you a way to say, hey LND, give me generate a transaction to send this amount to this address, and give me back the transaction so that I can look at it and see like how big is that transaction. So it's kind of all or nothing at the moment.
So you want some sort of dry run payment?
Yeah, exactly. We want a dry run. We want to be able to create a dry run transaction so we can see how big it is. Then we can take a fee estimation, like a fee estimate, and we can apply that, and we can give the user an option of like, you know, whether they want next block or next 6 blocks or whatever, and then we can extrapolate that out and show them the cost that they'll actually pay. The best we can do currently is basically say, okay, well, you know, it's 3 sats per byte. And it's like, what does that mean?
Yeah, I've done this with an application as well, but for using Bitcoin JS lib, I think you referenced it also. So you can generate your own transaction, count the bytes, and then use the fee estimation per kilobyte to figure out.
But how can you do that if your Bitcoin wallet is running on a remote LND node? like, how are you going to generate a transaction from that? You need access to the full node to generate the transaction.
You need to be able to get the UTXO, to
right.
what inputs you're going to spend.
That's it, but all we can get is what LND gives us, and it doesn't, unfortunately, give us that.
Okay.
I mean, maybe someone knows a way of doing it, but we haven't found a way to do that yet. But this PR1228 is a pull request to expose because LND does have fee estimation inside it, and this PR here is actually looking to expose that as a gRPC endpoint so that you can just say, like, give me a fee estimate for this transaction. So that would kind of solve for that. Cool, so yeah, so that's some of the new payment request forms. They're quite nice, they're quite more interactive now, like you can basically paste in an on-chain address or an off-chain address, it'll determine what it is, it will like decode the invoice, to show the user the details, and then they can kind of get the fee estimate and then hit send. I think one of the things I found when building this as well that was kind of interesting is that, so when you get an LND, like when you have a payment request, like we basically want to take that payment request and decode it. And like what we were doing previously is we were just sending that payment request to LND and having it basically decode the invoice, and it spits out a sort of representation of that invoice data. But like as I started to build this out, I kind of took this as an opportunity to do some like more refactoring on the app. And this kind of snowballed into building out a storybook for our app. So if any of you are sort of familiar with React development or that kind of world, that sort of world, like Storybook's a tool that basically allows you to have a kind of catalog, if you like, of all of the React components that we've created, and we can kind of see how they look, we can interact with them, and we can kind of see how they look and feel, and how we can build them together. So I've kind of gone through the app, I've extracted out all of the components, and we've got a full catalog of all the different bits and pieces. We have everything from like, the color palettes, and then we've got like, the typography that we're using, and buttons, and the different button states and stuff, like page layouts that we're using within the app and things like that. And, it kind of gives us like a catalog of all the different components that we've got to build with, and then we use those to build out new sections of the app. One of the really cool things about the Storybook is that this allows us to like build stuff without even like using LND or even starting up Zap. And what I found is that since I built the Storybook, I probably spend 80% of my time when I'm building stuff on Zap Desktop, I'm actually just building in the Storybook environment, which is literally just using like Chrome, just using my web browser. And so we have like, from in here, we also have like full like page mockups, which you can interact with. So you can also, what we do in here is we can like stub, what I found was that when we're building like stuff on LND, we'd often need to we're trying to build like a UI for some particular state. So for example, like if let's say you've made a payment, you're trying to make a payment and it's failed routing, and LND gives you back an error that says like routing failed, and we want to show the user an error that sort of explains to them that the routing failed and like what they can do about it. But in order to like actually build that into the UI and to test it, like that relies on us having like LND running. We've got to have LND synced. We've got to have some testnet coins, or we've got to have like some connections to the network. And like if you want to actually do that in like a kind of real world scenario, like it's work to get the app into that state so that you can even test that like failure case that you're trying to build for. And so in the Storybook, we essentially like have a mock like LND. We basically mock and stub the LND calls. So in the Storybook, if you go into like one of the pages, that's not a great example. Let me see the next one. I don't actually have a good screenshot that shows, but like for example, you can when you click on something within the Storybook, and where in the app, like it would actually call into LND and ask LND to do something. In the Storybook environment, because we don't have LND running, like we just like call into a mock function, and then we have that function return back to us like the data that we're expecting to see, and either the success case or like one of several failure cases. So we can simulate in here like success and failure of like all sorts of different things that LND might throw at us without even having to have LND running. So like this lets us be really productive in terms of building out UI, and we can basically build out new features in here, kind of work with graphic designers and kind of build get the UI fine-tuned, and then only at the last minute we then go and actually integrate that into the app and start running it using it with actual LND. And if we've done it properly and we've been mocked out those API results from LND properly, then it's pretty straightforward to integrate that. And so with some of the new stuff we've been building, I'd probably say it's probably 80% of my time in Storybook, and then it's just the last little hurdle to just go and integrate it into the app where you're actually running the app and connecting to the network. We haven't done a lot of work with SegNet or SegNet. What's the
RegTest?
Yeah, RegTest. Was it RegTest? RegNet? RegTest. Yeah. So we haven't really been using that. We've just been building against testnet. And we could probably simplify some of that by using at least we could speed up some of that process by not having to wait for things to be mined on testnet or something like that. But
Bcoin, I think that's the JavaScript Bitcoin.
Bcoin, that's the JavaScript one, isn't it?
Yeah. A RegTest Bcoin instance in the browser, so then and then some sort of fake, or maybe even a complete LND node in the browser. Possibly.
I mean, I'd rather not have, I'd kind of almost rather not, in the Storybook environment, I don't really want to have anything to do with anything that's just not JavaScript. I know Bcoin is a JavaScript implementation, but it's something that's pretty heavyweight to run in here, and we'd add some complexities, whereas if we just literally, just basically calling a function that gives us back data instantly, that's what we expect. We can craft those to represent what LND, what we see that LND typically gives us.
Yeah, mock LND makes more sense.
Yeah, we don't have a full mock LND implementation. It would be a nice thing to work towards. Currently we just stubbed and mocked the specific requests that we're trying to build against, So again, in the Storybook, so we're now building out, this is a new feature that it's kind of going through some testing and stuff at the moment, but what we've done here is basically, what we've seen is that a lot of people that are using Zap have kind of trying to connect to multiple wallets, and certainly I am as a developer building on it. I've got multiple testnet wallets and mainnet wallets, and people have got Litecoin wallets, they've got wallets up on BTCPay. If you're a merchant and you've got 5 stores, with Zap desktop currently, you can just basically connect to one node, and then when you quit the app, you basically start from scratch again. You have to go right through the onboarding process every single time. So here now we're storing the save wallet configurations, and you've got kind of a top level home area where you can basically access your different wallets. And you kind of only access this section if you need to. If you're just using one wallet, you don't ever need to see this. When you start up Zap now, it will basically take you to wherever you were last when you quit the app. So if you were in your wallet, and you quit Zap, the next time you start up Zap, you'll be back in your wallet. Now, if your wallet's locked, and needs a password to unlock, we'll show the wallet unlocker and allow you to unlock it. But we kind of remove some of that friction of having to go through the onboarding process every time. And then again, so you can have your different save wallet configs and you can tune your settings. It's pretty basic at the moment, but it's already useful. So you can configure, give your name a wallet just for, give your wallet a name just for kind of organizational purposes in Zap. Configure the alias, you can configure autopilot, and we've actually currently got some of the more fine-grained autopilot settings in there. But I think we're trying to strike a balance between what's what's kind of useful and what's complex, and are we building for power users or are we building for not so technical users? And I think currently we're probably building more for slightly more technical users in Zap, because I think that's mostly the current user base. Okay, so I wanted to just kind of finish off with some of the just general challenges and insights that I've had sort of whilst working through this whole thing. So the challenges in terms of the Lightning Network, slow sync times, I kind of talked about that before. If if you're expecting it, it's fine. It's fine to start up your app and wait 5 minutes and and have it sync. But it's not something that's you could say is consumer ready. So sync times is a pain, and it slows down your development flow as well. If you need to spin up a new node and get it into a ready state, you're going to be waiting some time before you can be productive again. So sync times are kind of painful, and just the general stability. of like, I mean, I guess I'm talking like specifically about LND because that's where like our focus has been. I can't really talk to like some of the other implementations, but the general stability of LND had been a problem. Like with the latest release, I'm really like impressed. It's really nice to work with because previously we were just getting like random seg faults and like memory overflows, and it would just like crash randomly and give us no log output, and it was kind of tough to work with and to know what was going on. That's really improved quite a lot. And then upgrading as well between the different versions of LND, like upgrades of the earlier versions, like you might find that a migration script didn't run properly, you'd end up with like a corrupt database, and you know, like if you're kind of technical, you could probably fix it and like get your money back. But like now, like with the latest versions, like even with like 4.0.4.0.42 and like the latest like 5.0 and 5.1, like these kind of problems seem to have gone away. I would say that, particularly in LND, like there's a lot of development happening. It's like really fast paced. There's PRs going in all the time, and you know, the rate I see stuff going in there, it kind of makes me question like how like thoroughly the stuff is being reviewed, and like how stable is it, and are these problems going to start reoccurring? But it's definitely like, you know, improved massively from 6 months ago, even when I started working with it. And just kind of keeping up is kind of tough. Like there's just so much stuff happening. I mean, I think René's going to be talking about some of the stuff that was, you know, going on in the kind of wider ecosystem, and there's just so much stuff. You know, whether you're talking about like splicing or AMP or like all these kind of terms that sound really cool and that would be really interesting, but like how much time can you dedicate to like researching these ideas and then actually trying to implement them within your project? You've got to pick and choose. So, you know, just keeping up with the space is definitely a challenge. And, you know, and I think on some of these points, so as I said, like the slow sync times, like they're definitely rapidly improving. General stability, I mean, like it's getting better, but I'd still say it's not ready for mainstream because like mainstream apps shouldn't like crash. You know, upgrade pain, again, like just it's getting better. And then like in terms of keeping up, it's just like, it's really interesting. So if you're kind of interested in this stuff and you're looking for like something to get involved with, and there's like no shortage of problems, like whether you're like a protocol developer or you're someone like me that's like more coming from a web development background. Like, I mean, I'm not a cryptographer, and you know, there's just a lot of different angles you can take with it. So, and that's kind of cool. And then like on the ecosystem in general, you know, like some kind of documentation issues, like we've seen sort of incorrect documentation or documentation inconsistencies, or you've got like, one thing I had like last week or the week before is just even within LND, like LND provides you with a REST API, a gRPC API, and a CLI interface. And like they're all the same thing. It's just 3 different ways of doing the same thing depending on, you know, what you're trying to accomplish. And you'd think that like if you wanted to run like the query routes command, that it would work the same like on the CLI versus the versus gRPC, but like that's not the case. You know, sometimes like I was trying to make a query routes call, and there's like 2 things you have to supply it, and one is like the payment request of the invoice that you're trying to pay, and then the other one is like the maximum number of routes that you want it to return. And like with the CLI, you just literally need to provide the invoice, and it will basically give you like by default, it just give you 10 routes back. With the gRPC one, like if you don't specify how many routes you want to get back, like you basically get an error. So when you're kind of reading the documentation and you think you know how the API works, like currently, like it's not necessarily the case that if it works that way in one interface that it's going to work the same way in the other way. So you've got to kind of cross-check those things. Like errors and reporting I touched on earlier, like just the error messages that LND spits out are very technical, and you know it makes sense because it's the people that are building, people that are using LND are going to be technical people, right? That's a lower level piece of software that, you know, people like us are using to build more high level stuff, and so the messages that LND gives out are kind of useful for us, but like really not helpful for anyone using Zap. So we get a lot of questions in like Slack, in Slack, you know, it's just seeing, I've got this error when trying to make a payment, like what does it mean? And, you know, that can be kind of tough. So we built like a bit of a sort of wrapper around error reporting. So we feed the errors that we get from LND into basically a list of kind of like a translation list, so we can kind of translate them into something a bit more human friendly. But like we've only covered some of the error messages, and like as we sort of see these error messages coming up, we're sort of trying to translate them into something that's a bit more understandable for end users. Yeah, some of the tools and libraries, I kind of touched on these things like seed generation libraries, like where is it? If I want to do like Bolt 11 invoice passing, like where is it? And in fact, like it's there. There's actually a couple of different implementations. And like, but one of the challenges like with that is that if you give an invoice to LND and you say like decode this invoice, like, it gives you representation. And like there's a JavaScript library using called Bolt 11, and you can give that a payment request, and it'll decode it, and it'll give you a representation of the same data, but like they're not the same. So like there's no standards as to like how to display that decoded data, or like what order things should be in, like where should the data be. So like when we're working in the Storybook environment, where we're kind of like mocking LND, and we want to be able to take a payment request and decode it without actually touching LND, and we're using like a different JavaScript library that's giving us like different output, the same data but different output format, and then when we try and integrate with the app, we find that there's some differences, and just kind of spotting that can be tough sometimes. So like the ecosystem like is definitely immature. You know, there's a huge scope there for like tools and libraries and things. So yeah, I think I talked to most of the like sort of points here. Like, you know, with the documentation issues, definitely like cross-check across different implementations, like whether it's inside LND itself, or whether it's like LND versus like Eclair or whatever. You know, the errors in reporting, like source code. I just take those error messages, go into GitHub and just like paste in the error message and try and find the code where it's coming from. And then at least you can have some kind of context, and you can take that into like LND Slack, and hopefully somebody there can kind of help you with what's going on. And then yeah, with the tools and libraries, like I think it just says to me that there's a huge scope for new projects. Like, so if anyone's kind of looking for like how can you build something that's useful, and you know, there's a lot of things that you could just build, like little utilities that would just be really useful and would be a good kind of way to sort of make some inroads into building stuff, and then you can kind of, you know, snowball out from there. And just on the user experience, so like, yeah, I talked about this, you know, bootstrapping the network's just slow, bad user experience. Routing basically doesn't work, bad user experience. Some of the core concepts within the wallet, like inside Zap, you've basically got two wallets, right? You've got your on-chain like balance, and then you've got a balance that's in some channels. And so you've got to present the user with these two different balances and like help them understand what they mean. Like, and if you've got money in some channels, like you've got 0.2 Bitcoin in some channels, and like 50% of that's in one channel, and then the other 50% is like spread unevenly between 6 other channels. Like, how do you know, like, what's the maximum that I can send like to this person at any point in time? Like, and there's no definitive answer. Like, it depends when you ask the question, and like how good your connection is to the network to know like how much can you actually send, and try to like sort of decode that and sort of present it to the user in something that they can understand and not be confused by is hard. And I don't think we've done it. You know, but I think as we kind of iterate on the software, we can try and kind of improve that. And but it is like kind of a real core concept. It's like the channels aren't going to go away. Channel balances aren't going to go away. Maybe when we've got like AMP or something like that, or we've got some kind of automated like rebalancing system in place where you can just have like the software just behind the scenes rebalancing everything for you, and then you have like one number that you can show the user, and this is like how much you've got and how much you can send. But currently, it's not the case. So that's a big user experience challenge. So yeah, I think the interesting thing here on the bootstrapping the network is that like what that says to me, because there's a real problem with the sort of network bootstrap process, it says to me that the user base currently is actually technical user base, because like if the majority of the people that were using like Lightning were non-technical users, like we'd be hearing about the network bootstrap pains like a lot more than we do. And I think the fact that like people that are using it know that it takes like a few minutes to synchronize, and that's kind of like expected. So it must be the case that most of the people using it are actually technical currently. You know, with the routing, I would just say like it's a bit of a concern. And like, I wouldn't say it's like an unsolved problem. I know lots of people are working on different ways to solve this. I think that the current solutions are not adequate and they need a lot of work. until we've got like 99% success rate, like it's going to be continually presenting problems to users. So when you're talking about kind of consumer-facing applications, like you need something that just doesn't fail. And then all these core concepts, I said like with the wallet balances, we just need to keep iterating on the software basically and keep taking in feedback from our user base, keep tweaking it, keep tuning it until we get something that people can just understand. And I think this just tells us, I think when we're talking about building for power users versus end users, I think what it tells us is that like we're at really early days because like I think when Jack started the project, the goal was really to build something that's for end users and like make Lightning simple to use. And I think he really succeeded in that, in is to say that before like there was Zap and some of these other like UI-based wallets, the only way you could interact with Lightning is basically by being like a techno geek and command lining stuff. But we do have applications now that are more end-user friendly, but the fact is that like the vast majority of user base is technical, and so it makes sense at the moment for us to be building for a slightly more technical user base, like things like giving them control over autopilot and their allocations, letting them see the channel management, letting them use those features. We've had some people in Slack kind of asking about like, this is too complex, why like how are end users going to use this? And I think like the answer right now is that they're not, because like they're not the current audience. Like we're still building a network, we're still building like the protocol, so we can't really be building for end users yet, but we can start that process, and that's kind of what we're trying to do. So just to wrap up, like I think some of the next things we're going to do with Zap, we're just going to keep refactoring basically, just keep improving the code base, improving the UI. And we're going to try and fulfill the mission that Jack set out to do, which is to make Lightning Network accessible to people. We'd like to do some sort of deeper integration with like our mobile wallet, for example, or with some of these hardware nodes. Like I think I haven't actually used them myself, but like the Raspblitz nodes and like the Casa nodes and these sort of little hardware, Raspberry Pi devices. Some people have built some sort of integrations that allow you to connect Zap really easily. But we'd like to get some kind of like deeper integration with those tools so that people that are using those nodes just have a really easy way to connect their Zap wallet and use that as their kind of remote control. And I think we'd like to get on to looking at sort of channel balancing re-strategies. I'm not too familiar with what's going on in the space in terms of like the sort of the lower level at the protocol level. But I think until we start seeing stuff at that level, like maybe we can start building something on a slightly higher level to give users some tools to help them rebalance their channels. Maybe that's a manual process to start with, and eventually maybe that can fade away into the background. And then we want to start looking at other really cool stuff like submarine swaps and start some more of the sort of fancy stuff that's going to just make like the thing easy to use. But like for us, as building on a higher level, like we need some of the stuff to be more stable and kind of built into the base protocol before we can really start using these types of things. We don't want to be building on these kind of like new features where the API is just going to change out from under us. But we do want to keep integrating new cool stuff into the software. And I'm just going to leave you with a couple of resources that I think are really, really useful if you're in this space, if you're trying to keep up. The Bitcoin Optech newsletter is like, I don't know, is it weekly or bi-weekly? It's weekly. It's really awesome. They just send out a newsletter. It's like takes you about 5 minutes to read it, but they summarize the key things that are going on in the space, and they focus on like Bitcoin Core and like LND and Eclair and C Lightning and that sort of Bitcoin on-chain, off-chain crossover. And they just pick out like some of the key things that have gone on, some of the key developments, some of the key ideas that are coming through. So you should definitely subscribe to that if you haven't already. LND Slack, there's like thousands of people in there talking about LND and Lightning and asking questions and like helping people out. So if you're building stuff, you should hang out in there. And for us, like as we're building quite like closely on top of LND specifically, like keeping track of their GitHub milestones like gives us a sense of like what when their next release is going to be, like what's going to be in that release, because we can literally see all of the stories that they've got kind of lined up for the next release, and we can kind of make sure that what we're building like starts incorporating some of that stuff as well, sort of as it's before it comes into the release, and then when it's into the release as well, we can start pushing that out to our users. HTLC.me, really cool site. If you just need to generate an invoice and you don't have like LND running or something like that, you can just go to htlc.me and you can say, give me an invoice, and it'll give you a Lightning invoice. And you can then kind of use that, decode it. And like if you're building software on top of Lightning and you don't want to have like a node running so you can get an invoice, you can just jump over there and it'll generate you an invoice. And then like if you want to help out with Zap, or you've got questions on Zap, like come and ask us in Slack, like we're in there 24/7 pretty much. Cool, so I think just to finish up, like I would say that like if I want you to take something away from this, I mean, hopefully I've given you a sense of like on a slightly technical level, like some of the things that are involved in building out like applications on top of Lightning. And I would just say like here, like if you've got some kind of experience with like web development or just development, then you're probably qualified to start building stuff in this space. So like don't be scared off by like the fact that there's cryptography involved or something like that, because you can come in at a higher level. You don't need to be building on the protocol, and you can be building out, whether it's like the little hardware device over here that dispenses M&Ms, or like a software wallet like this that's really just a React, like JavaScript web app that's just making API calls. If you've got some kind of just development experience, like you've probably got what you need to start building cool stuff on Lightning. So thanks guys. If anyone's got any more questions, please.
Has anyone worked on C-Lightning integration?
For Zap?
Yeah.
Not that I'm aware of. I mean, I certainly haven't, and I haven't seen anything. I know some people have built like, it does actually support like Litecoin as well. Some people built made sure that it would work for that. But like,
is there enough abstraction in there that somebody could even do that? Because it sounds like you have a lot of very tight coupling with that.
I would say like we're getting to the point, like I'm trying to really like abstract things out, and like building out like mock interfaces and things like that is a step along that line. Currently we're pretty tightly coupled, but I think there's no reason in the future why it couldn't support. Yeah.
So there's Zap Wallet for iOS, there's Zap Wallet for desktop.
Yeah.
How is about Zap Wallet for Android? When I hear about it's kind of almost a web app in a native container deployed to desktop systems. There are also techniques out there to put this into a mobile container and run this on Android.
Yeah, there are. So like the L&D team, like Lightning Labs, are building out like their wallet. I think it's called Lightning App. And that is a React app as well. They're using React Native, so they have one app that basically runs in all the different environments, like iOS, Android, and on the desktop. Like, we took a slightly different approach with this. Like the iOS app is written in Swift, and it's a native app, and like there's some kind of inherent advantages with that. And like also, like we're focusing on slightly different like use cases as well. Where, as I said, with the desktop app, we're trying to sort of build some slightly more technical tools into it. So it's not like there's a one-to-one mapping between the functionality that we even want to provide those apps. So in terms of Android, like I don't think anyone on the Zap team like really uses Android, so that's why it's not being built. But if someone wants to build it, maybe if there's enough interest, we'll build it. But I haven't seen that many people asking for it. Yeah. So
if you want to support the other Lightning implementations, I think that would be super, super useful, because there's already Christian Decker's Lightning integration repo, and I mean he's already trying to support multiple nodes, because then he can test like channels from EPI to LND and vice versa, and with a node in between, and all different kinds of implementations and all that. So I mean. Yeah, so I think it would be so useful to have a proper API that would work against all nodes, right? For managing and for basically doing all these things, because all the implementations are supposed to be doing the same stuff. Yeah,
that's right. I mean, and under the hood, they are like compatible with each other on the protocol level. I think, when the app started to be built, like LND seemed to be like one of the more popular implementations. I'd say it probably still is, but maybe that's just because I'm so in that space. But I think as all the different implementations start to get like more and more people start using the different ones, it would be a shame if we're just tied to LND and there's like 3 other implementations and 2/3 of the user base that can't use Zap because of the particular like LND node instance they're running. So definitely something I'm keen to look into. In fact, when we even like in terms of like coupling and tight coupling, like when we were building the BTCPay Server integration, Nicholas really wanted to have he wanted to expose the REST API, and like we wanted to use the gRPC API because that's what that's how that works today. And it's definitely like, it shouldn't be too hard to have like an abstraction layer within Zap where you can basically use REST and WebSockets if you want to talk to the REST API, or like gRPC if you want to use that. And you should be able to use both. But like currently, because like Zap just kind of evolved out of just building for a specific use case, like there's a tight coupling with gRPC. But you know, there's nothing, I think there's nothing that much in the code base that would make it actually difficult to do that. Like the code that integrates with LND is like, you know, in a couple of specific places, and there's not that much like we do really, you know. Like with gRPC, like the gRPC just gives you an object that you can like natively use in JavaScript. Like currently we kind of have like, it's not done right at the moment because we currently basically have like our own little REST API on top of gRPC, and then as we communicate between the renderer process and the main process in Electron, we're basically communicating with the REST API, which is then telling gRPC to do stuff. So like, but we can definitely change that, you know, and there's not too much code involved to say, well, we could use like REST and gRPC. And on the same token, I don't think there would be that much involved to say, okay, you can use this node implementation or that node implementation, but today it's not there.
But I just wanted to encourage you to make it separate from Zap, right? Because then it could be useful for testing, and then you might get other contributors, right? And then you might get an interface that supports everything and not just what Zap wants to do, and you know, win-win.
Yeah, definitely, definitely. Yeah, I mean, I think we're trying to, like, everything we do is open source. A lot of it is kind of embedded in Zap at the moment. Like, there's a couple of libraries that we've taken out and extracted separately. We have a library called LND binary, which lets you just really easily install LND. Like, it lets basically, you can do npm install LND binary, and it will like go to GitHub. It will fetch the LND binary. It'll like download. It's got a repository of the checksums. It will like validate that it's the right binary, and it will kind of extract that and then make it available for use in Node. So there's things like that where we're starting to pull out some of that functionality and extract it out into separate libraries. But yeah, and I think if we get to the point where we're building like an abstraction or like an API that just basically can spit out to 3 different node implementations or however many, definitely would be something that we would open source outside of the context of Zap. Cool, all right, well thanks very much guys.
Okay, well thank you very much.